WireGuard is a fast, modern, and secure way to build your site-to-site tunnels with Pfsense. Now, I have done a previous video on this topic regarding device access, and you'll find that one linked down below. This one's focusing on setting up two Pfsense systems and doing a routed site-to-site tunnel. So let's get started. A seemingly normal login can be a red flag. It might not be you accessing your system, but a threat actor using stolen credentials. This is unwanted access. Huntress watches out for sneaky tactics and behaviors, like credential theft and session hijacking. With Huntress, you get their expert team monitoring your system 24/7, identifying and responding to threats early on. Protect your identity and your business from unwanted access, business email compromise, and more. Start your free trial today with Huntress Managed ITDR. I do like their fast, modern, secure slogan that they have for an open source project. I think it's pretty good. Let's focus in on the setup here for our lab. We have the WAN at 100.69.69.43, and the other WAN is at 100.69.69.44. This is my lab setup. See my lab video to better understand how I do things in the lab. But yes, the two systems can completely talk to each other, and that's fine because the goal in this video is to show you how the devices behind these Pfsenses can talk to each other. So we have a LAN on one side of 192.168.234.1/24, and on the other side 192.168.177.1/24. With WireGuard, you have to build a tunnel network. Now, I define this tunnel network with 10.69.69.0/24. That is not necessarily something you'll use in production unless you happen to have an absolute ton of tunnels that you plan to create. What you need is a subnet, though, for the tunnel. The subnet's generally going to be smaller, but for simplicity, I just put a /24 because that's going to be, well, something that creates the least amount of questions down in the comments below. Of course, you can break this down to a much smaller piece of a subnet, and at the end of the video, I'll show you one of my production setups and how I have that configured. But for simplicity's sake, we're just keeping it really simple. We have to assign each of the devices, and there's only two, Site A and Site B, an IP address within the tunnel range. Because what happens when you want the data to go from where it is to where you want it to be across the tunnel, it has to traverse the tunnel to get there. So we need IP addresses assigned to the tunnel, and then we need routes to understand what should or should not go over the tunnel, and that's what we'll be covering is how to get those configured. Now, how WireGuard works is not in the traditional client server. So you don't designate one of these sites as a server and the other as a client. They're all going to be peers. First, we have the primary tunnel, and then we have a peer. And this is a symmetrical setup. Essentially, we have the public key of Site A in Site B, and vice versa. And this is going to be true as we go down and set this up. You set up everything with symmetry so that each one, provided you want this type of access, which is to be able to have Site A talking to devices on Site B, you'll create a symmetry for each route. You'll need a route to understand how to route the LAN on one side to the LAN on the other side. And if you were to have multiple subnets, multiple LANs, or whatever purpose you have them designated for, maybe server networks, etc., you would have to create routes on each side for these. I will show how to do the rules as well so you can control egress, ingress of data across these routes, or maybe you want to filter to specific things. We will get to the firewall rules later. Now, the further explained peers, you can see that the public key that is built on Site A is set up in the peer of Site B, and vice versa. The public key on Site B is the peer for Site A. This is what I'm referencing when I say that there is no client server, just peers, and the symmetry between them for where these go. We're going to show you how to set up now in practical inside of Pfsense and go through the steps. Now for this demo, I'm going to keep things as clear as possible. Site A, as noted at the type here where it says Site A, is going to be set to light mode. And then, of course, dark mode is where we'll do most of our work here on Site B. I'm going to walk you through all the steps, but I want to make sure it's clear when I'm on Site A versus when I'm on Site B. I will note right here is the WAN IP address of Site B at 100.69.69.44 and 100.69.69.43 for Site A. And you can note that the LAN address is a 192.168.234.1 versus 192.168.177.1. These are exactly as they were in the diagrams that I referenced earlier during the slides. First step is going over to VPN and WireGuard. Now I already have this WireGuard tunnel established. Establishing new tunnels is relatively easy. You simply click Add Tunnel. It will default to 518.2.0, but we've already got a 518.2.0, so it increments one more up, but you could also choose your own port for the listening port. Then you click generate, and then you will have to save this tunnel, and then it'll allow you to add peers. So let's go and look at the existing tunnel, and we'll show you how the peer adding works. So we took the tunnel right here that we've already created here on site B, and we've got this public key for the tunnel, and we hit copy. We would go over here, and we've already got the peer established, but if we were to add a new peer, this is where you would paste the public key, and then from there, build out the peer. And as I said, they're symmetrical like I've shown. Now, let's get a little further and look at what these peers contain. Besides the public IP address, each peer, we'll edit the peer here, has to have the allowed IPs. So the first allowed IP is 10.69.69.0, which is our WireGuard tunnel. I just chose this address because I like internet funny numbers. You can choose whichever you want. As I noted earlier, /24 may not be what you want in production because it's a rather large subnet for this. You can choose whichever one works for you, but I'm not going to get too deep into subnetting out of scope of this particular video. The next one we want is the Site B LAN. So we want the allowed IPs to be the allowed network from Site B. That means this can traverse the tunnel. Any other networks you have that you want to traverse the tunnel, you'll have to add them here from the other site. So you're on Site A adding all the networks that will be coming across from Site B. And this works exactly the same way, where we have the common WG tunnel, same address, and these do have to match. So if it says a /24 here, it needs to be a /24 here, but you can see now we have the Site A LAN on here. So 192.168.234.0/24 is Site A LAN versus Site B LAN. This means both of these can traverse this network, and of course, if you needed to add more, you can simply add them. Now, the next part I want to talk about is the tunnel itself. As you create new tunnels, and we'll just create a test tunnel to show you what it looks like. Test, generate, save tunnel, hit apply, and there'll be a shortcut if you go to edit it for your interface assignments. We already have one established I call WG demo, but if we wanted to add another interface, and that would be the next step, we would add the interface here. But let's look at what goes into adding an interface. Click on WG demo. You give it a name. The MTU should be set to 1420, as should the MSS. Out of scope to get in a longer explanation, but the too long didn't look this up and read how WireGuard works. You need to have an MTU slightly smaller than the standard 1500 MTU to be able to encapsulate this without a problem. And that problem being a lot of fragmentation. Now for the static IPv4 address, 10.69.69.2. We could have made this .3, anything that is within that /24 range. Now I've already added the gateway, but you would also add a new gateway. The way you add a gateway is click the Add Gateway button. You do not want to make this the default gateway. You would give this a gateway IPv4 address, and it would be the 10.69.69.2. So in the end, and we're going to go over here to System and Routing, and you can see the gateway, which I can edit here. WD demo is the interface it's attached to because we've already got the interface established. Now the IP address of the gateway is the same IP as the interface because you create the interface and then create the gateway. May seem confusing, but this does have to be the same IP address. Then for the monitor IP, this is optional, but I like to set the monitor IP to be the IP address of the system on the other side, which means if we get over here, we see the gateway and also the interface address is 10.69.69.1, and it's monitoring Site B's IP address of 10.69.69.2. So you can see the symmetry between them where they are looking at each other. What this allows you to do is when you're on the main Pfsense page, you can see the ping times for your existing gateways as they go across the tunnel. I have the WireGuard established right here, so we see that there is some data going across, but with the YouTube demo gateway and monitoring it and monitoring the other side, if the gateway goes down, as in the WireGuard tunnel stops, I will actually get a gateway notice that is offline. Well, let's go back over to VPN and WireGuard, and I'm going to get rid of this extra tunnel because we're not going to assign this one. If we delete this one here, hit OK, and hit Apply, I will note that deletes extra tunnels that are created, but it does not reset any established connections on existing tunnels. The only time that Apply messes with existing tunnels is when you change peers that are nested under this particular tunnel. Now let's go back over here to System and Routing. Something else I want to point out. We do have this gateway right here. And of course I have my WAN DHCP gateway. Yours may be a static gateway, depends on how your WAN is set up. Do make sure you change the default gateway to be whatever your WAN is. You don't want to cause problems by having it set to automatic, because if it's automatic, it may jump down the wrong gateway. So I haven't set it to be the WAN for the default gateway, because now this thing we need to establish is how do we get things to go out this gateway? The way you do that is with static routing. So we go here and we put in the address destination for site B. Then we would choose the gateway we want this to go over. And just like the description says, route to site A network. And over on site A, we have exactly the same thing. We have the site A network range of 192.168.1770. There's our gateway for this, and it's routing to site B. That means anytime there's a request for something on that particular destination network, it shouldn't go out the WAN, it should go out this particular gateway. This works as well if you had multiple gateways that are across different WireGuard and not just a site A and site B. What if you had site C, site D, etc.? You would build these gateways and each of these static routes so it knew where to send that network data and which gateway to send it out. You can also go over here to Diagnostics, Routes, and you can see the different routes here. And at the bottom, we have our ton WG0, which is going to be anything destination for that network should go over this particular tunnel. And we see the same thing over here on site A. Now let's talk about the firewall rules that are needed. First one's going to be, of course, WAN. We edit the WAN rule that allows WireGuard, interface WAN, IPv4, UDP, source any. But of course, if you needed to filter this to a specific alias or specific network because you didn't want to open it to the world and you had two sites with static addresses, it would be better to do that because you're not mitigating anyone noticing that you have a port open. Then we have a destination of WAN address, 51820, because that's what we have established in WireGuard. 51820, we only need this one destination port range. Of course, if you have multiple WireGuard tunnels and you wanted to do a range, you could do that here. And I just called the rule allow WireGuard. The next rule you'll need is going to go under not WireGuard, which you'll see there are no rules. You can go here under the tunnel we have established, and we call this one WG Demo. This is simply an allow all rule. And we have them the same on both sides. So on site A, we have an allow all, and on site B, we have an allow all. Now that we're done with the firewall rules, let's go to VPN, then WireGuard. And we'll go to status, expand this out, and you can see that site B is connected to site A as of 59 seconds ago and able to talk to it. Now, if you reference back to our diagram, you'll see the IP address of the two machines we have behind each of these. The top one is site A. So let's look at its IP address, and it's the 192.168.234.12. And this is site B, so it's behind that firewall, and it's at 192.168.77.10. So let's go ahead and ping site A. And we see that works. And we can do the same. We go here and highlight this IP address, copy, ping, and we're able to ping from site A to site B and vice versa. Now let's talk a little bit how the firewall rules work. So right now I'm able to ping from site A to site B. What if I only wanted site B to access site A, but not the other way around? For that, we'll go over here to the firewall rules on site B, and to block site A, we're just going to disable this rule. So now there's no rules available, which means I can reach out from site B to site A, but the traffic can't come back in. So if we go to site A and try to ping, we get nothing. But if we go to site B and we try to ping, we're able to access that network. And of course, if I did this, let's go ahead and re-edit the rule, apply, switch back, and immediately it's able to ping again. This is where you can get granular with the rules. You can go through like any other firewall rules in Pfsense, get very specific about which IPs, if maybe you have a specific list of which ones can access on each of these, this is where you would do this. Reference the Pfsense documentation or some of my previous videos in terms of how to set up more detailed firewall rules. Now the scenario as we started at the beginning of this video was assuming that both site A and site B had public IP addresses. I know this is my lab, so they're not technically public IPs, but for sake of argument here, we're going to talk about site A still being at 169.69.43, and we'll pretend that is a public IP address. And then we're going to do a standard RFC 1918 address of 192.168.13.16 at site B. And what happens here is site A is not going to be able to initiate a WireGuard connection to site B. But we can take site B or any other number of sites, have them behind something like NAT, and have them reach back out to site A, the site that has the public IP address, so the connection can be established. Now over here on site B, there's really nothing we have to do. If we go to the peers that are under this particular tunnel, it's still going to establish a connection to this endpoint, site B. But I might recommend, if there's not regular data requests coming from site B to site A, because site A can't establish, but site B can, you can set a keep alive time. Let's say every 30 seconds. What this will do is every 30 seconds, it will automatically try to reach out to site A at the static IP address that we have here. And we'll go ahead and hit save. That means if for some reason the system goes down and comes back up, it won't have to wait for someone to request data to reestablish the connection. It'll just keep pinging it essentially and reestablishing the connection. So we go here to status. We can see that it still has the connection established and it's going to keep that connection alive. Now, if we go over here to the tunnel on site B and we want to edit that particular peer, I've checked the dynamic endpoint. That means don't reach out to the endpoint. We don't put that IP address here at all. We just set it to dynamic, as in it can come from wherever that other site B IP address is that's public. It doesn't matter if it moves. It doesn't matter if the IP address changes. It's going to accept that connection. Now, keep alive here doesn't really help you as much. Obviously, it'll keep alive and try to establish once it's established, but because it's dynamic, it doesn't have any way to reach out because it doesn't know where site B will be at any given time. So these are ways you solve that, is simply by putting it on the side that is behind a NAT. You would edit that particular peer to point at the static IP of site A or whatever system has the static IP. So it's always initiating a connection from behind whatever firewall it's behind and then reaching out and doing a keep alive to say, keep that connection going. Now, one more thing I want to make note of is if we go to firewall NAT and then our outbound, we have automatic outbound NAT rule generation, which is the default setting in Pfsense. And you'll notice because we added these static routes, they're in here. So we have the WG demo interface and we have the static routes from when we went over here to system and then routing and added them. But because we're not natting any of this, we're putting this as a routed network. So the IP address as it appears from site B or site A, when two devices are talking to each other, they see that IP. They're not natting through Pfsense at all. It's actually doing routes for all of these networks. Now, as I said at the beginning of the video, we'll talk a little bit about my production setup. And no, this is not my public IP address. Matter of fact, I want to point out that my WAN is DHCP. I do have a public IP, but occasionally that can change. We do have this PA VPN here. This is from a previous video on Privacy VPNs. You'll find that link down below. And I have my LTS Office WireGuard VPN and the CNWR Lab VPN. This is from the lab video I did recently. Now, these you may notice are both at 1055, but they're completely different tunnels, and let me show you how that works. Also worth noting, that setup I said where it is dynamic on the static side, both of these are set to be dynamic because my IP address can change, and I'm the one reaching out with my VPN to establish a connection to these. So if we take a look first at the LTS Office one, you'll see it's 1055.55.0/30 WG tunnel. For those of you familiar with how that subnet will work, there's only a couple usable IP addresses in here. One's assigned to the gateway on my side, one's assigned to the other gateway. And the same goes for when we look at the CNWR tunnel. The allowed IP range is 1055.55.4, but also a /30, which means IPs 5 and 6 are usable, and those are the ones assigned to each end of the tunnel. And if you look at the gateways, it works much the same way. So we have 1055.55.1, 1055.55.2, and because these are split off into just a couple IP addresses, that we were allowed to use 1055.55.6 and 1055.55.5. Then if we look over here at our static routes, you'll see all the different routes that go over to the LTS one and the CNWR one, and you can see the corresponding gateways for each of these static routes that I added. Now, I know at the beginning I mentioned, and this will definitely be coming up in the comments, having a tunnel network of a 2.0/24 on an RFC 1918 range is great if you plan to add a lot of peers, but obviously it's a very large range for a tunnel network. And the opposite is true for what I just showed you with my 10.55.55 network. By doing a /30, I only have 2 IP addresses. And with only 2 available, that means I can only have 2 systems on there, and now there's 2. There's mine and the other end. So from a planning standpoint, you do need to make the tunnel network big enough for what you need and big enough for what you want later. So if you want to have 5 peers, you'll need a subnet at least big enough to handle 5 peers in it. So do your planning accordingly. One thing to note, and this is where I've seen people get really stuck on WireGuard, is they go, well, I'll just do this /24 network and do a very large one, but I want more than one tunnel. The tunnel network can only be assigned to one tunnel. Well, technically, it'll let you assign it to more than one. It just won't work properly because you won't know where the route goes. So if I were to establish a tunnel network and then reuse that same network range or IPs within that range, you have a problem with routing at that point of which tunnel does it go on. Does it go on this subnet or that subnet? Because now they're crossing over each other. These are those little things that from lots of consulting I've done have seen people do, and that was where they were beating their head against the wall about this. Now, I do have the diagram uploaded to my GitHub if you want to go through and set this up yourself and do things in the exact same way, and just so you're copying and pasting exactly as you see in this video to kind of get an established way to get WireGuard going. That would be great if that's something that would be helpful to you. That's why I provide those. If not, head over to my forums, forums.lawrencesystems.com, where you can have a more in-depth discussion about this and other topics. Also, take some time to check out the Netgate forums. There's a lot of discussion, especially on WireGuard, a lot of different scenarios. There are a lot of complex things you can do in Pfsense. That's one of the reasons I like it so much because, well, this is hard to do in a lot of other firewalls at the scale, especially for what you see here at my lab and studio environments is very small potatoes from some of the larger things that we have done for clients that have data traversing data centers with even more features or even more complexity due to the nature of what they need done. And Pfsense is able to handle both sides of it. Like and subscribe to see more content from the channel, and I'll see you online at whatever socials you can find me on at lawrencesystems.com. Thanks.